Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about a Leetcode question number 139, word break. Given a string S and a dictionary of a string's word dict, return true if S can be segmented into a space separated sequence of one or more dictionary words. Note that the same word in a dictionary can be reused multiple times. So this is this one condition they have given. Okay. Now see here, lead code, and in dictionary there is lead and code. So obviously I will be taking this lead and this code to merge them to give this resultant string. Okay. Meanwhile here, apple, pen, apple. So here apple, then pen, then apple. Simple. Okay. Now here it is cats, and the same D is going for the dog also, but there is no thing like cats. There is a cats. Okay, there is a and, but there is no OG. There is no OG. If there is OG, then I'll be just returning true, right? But since there is no OG, we cannot return anything. We will be returning false. Okay, fine. So what is the logic behind it? So the logic is simple. Just go along the string and take each and every substring and check whether that substring is present or not. If it is present, then go to the next substring. Else at last just return false. Okay. For example, see here, I'll be taking a simple example first. Then we can go to this example. Okay. So the simple example is cat and sand. Okay. So just see, this is the word dict, hats off now. Okay, and this is the given string. Okay, now initially I'll be taking a pointer here and another pointer here, and it means I have C as a substring. Now I'll be moving my pointer apart. Now CA is my substring. Now CA is not present here, right? CA is not present. So okay, go apart. Okay, now CAT, whether CAT is present? Yes, it is present. So what should I do? I will just making this pointer to move next, and this pointer to move next. Okay, now this will be straight out. Now what is the word? It is yes. Whether S is present? No. Just move on. SA, whether SA is present? No. Just move on. Now SAN is present? No. Just move on. Now SAND is present? Yes, it is present. So SAND is present, right? So at this point, what should I do? I'll be moving this pointer adds of no. So this upper pointer will be moving one step ahead always, but this lower pointer now move to end. So from here I can say this is going to be the approach, right? So this is going to be the simple approach. At last I will be checking whether these two pointers are at the end. At last, if it is so, then I'll be return what? I'll be returning true. Else I'll be returning false. That's it. So this is going to be a initial approach. But if I take the same thing, the same example, and then now the word is going to be like this. The word dict will be going to be like this. Then apply the same logic. So initially I will be starting here and starting here. Okay. Now at first C, whether C is present? No. Okay, move on. Whether CA is present? No. Just move on. Now whether CAT is present? Yes, CAT is present. Okay. Now what should I do? I'll be moving my pointer to here and this pointer to next. Can you understand this? Okay. Now yes, whether S is present? No. Now move on. Whether SA is present? No. Move on. Now whether SAN is present? No. Move on. Whether SAND is present? No. Then move on. That's it. So end. So my upper point came to the end, but my lower point is not came to the end. So here, from here, what I can say? I can say it is false condition. It is a false condition. But we can actually construct it, right? So at first take this cats, then at second take this and. So we can construct this word. But as of now, our answer is what? It is false. So from here I can tell you our approach is failed. Our approach, the greedy plus 2 point approach, what I have used here, right? So this approach is failed. So whenever a greedy algorithm failed, where we will be going? We will be going for a combination. See here, just use a common sense. See here, when I came here, when I just came to here, like one pointer is here and another pointer is here. Okay, so CAT. So here I have took the CAT and made these 2 pointers to reach the next index, right? Obviously. So instead of doing that, I have two conditions. I have two possibilities. Okay, one possibility is after this make my 2 pointers to reach here, or else don't do anything and make this to move here alone. Can you understand this? So till now, if you cannot understand, see here, this is going to be a recursion approach. Okay, now I'll be telling you very much clearly. Okay, so please pay patient and attention so that you can understand this clearly. Okay, so before getting into it, you want to know about the recursion stack and recursion tree. If you don't know about that, then it will be much more difficult to you to understand. Okay, fine. So initially I'll be having a function for every recursion, right? So here what the function will be. So that function will be having 2 pointers. One is the lower pointer, another one is the upper pointer, right? So the function will be having 2 pointers. Okay. Okay, fine. Now what should I do? What should I do? If the substring from I up to j, the substring, just listen to me, the substring which is from I to j is present in my word dict, then only I have 2 choices. Otherwise I have only one choice. What? Just to do j plus 1. That's it. Can you understand this? So let me go and construct this recursion tree so that you can understand this clearly. Okay, if you cannot understand till now, just watch this. Here is only we are starting this problem. Okay, till now I told you why we are not using the greedy algorithm, and I gave you the short note on how we are just rethinking and reconstructing the solution to achieve the recursion. Okay, now we are getting into the main part. Okay, so initially I'll be starting from 0, 0. So here and here. Okay, let us take the word dict as cat, cats, and. Okay, so this is what we failed in the greedy algorithm. So I took this. Okay, fine. So listen this. First of all, 0, 0. What is the substring? It is C. Whether C is present here? No. Whenever it is a no, then go for 0, 1. Just increase my 1 count for the substring. So now, what is 0, 1? Let me take this pointers. Okay, this pointers, instead of this pointer, I will be highlighting the characters. Okay, now 0, 1 means what? CA. So whether the CA is present here? No. Then what should we do? Go to the next. Okay, now whether CAT is present? Yes, CAT is present. Whenever it is present, we have 2 choices. We have, so one choice is either take it. Which means, hey, move to 3, 3, which means I have taken it. Or else I have another choice like, hey, don't take it. Just go and proceed what you are done. Hats off. No. Can you understand this? Yes. So cat is present. That's the reason why we have got like this. Okay. Now 3, 3. So 3, 3 means this yes. Whether this yes is present in our dict? No. At this point, what we will be doing? 3, 4. Yes. Simple. Now 0, 3. 0, 3 means these 4 characters. So cats. Whether cats is present? Yes. It is present. So at this point, what should I do? I'll be having 2 choices. One choice, hey, take it and go to the next, which means 4, 4. Can you understand this? The same logic we have done in the 2 pointers. Now we are just dividing into two types, the 2 combinations. Okay. Now here what it will be? It will be like 0, 4. Don't take. Okay. Now 3, 4. So 3, 4. Whether SA is present? No. So just go on. So 3, 5. Whether 4, 4 is what? A. Whether A is present? No. A is not present, right? So I'll be going for 4, 5. Okay. Whether 0, 4. 0, 4 means these entire line. So these entire string is not present, right? So just skip and go to the next thing. Okay. Now here 3, 5. So 3, 5. So whether SAN is present? No. So what we are going to do? Go to the next thing. Okay, now 4, 5. So whether AND is present? No. Then what should we do? I'll be going to the next thing. Okay, go to the next thing. Now 0, 5. 0, 5 means this entire thing. Whether it is present? No. At this point, what should I do? I'll be going to f of 0, 6. Okay. Now again. Here 3, 6. So 3, 6 means S-A-N-D. Whether sand is present? No, no. So at this point, where should I go? I'll be going to next point. So 3, 7. Okay, now 4, 6. Whether 4, 6 is present? Yes, yes, and is present here. Just a minute, I'll be saving this. I don't know when my laptop will crash. Okay, fine. So and is present, right? And is present. So here I can tell you we have two choices. Here we have two choices. What are them? One is, hey, take it and go to the next. Or else, hey, don't worry. Just don't take it and go to the next. Okay, fine. Now 0, 6. 0, 6 means I will be taking whole string. Whether this whole string is present here? No. At this point, what I am going to do? F of 0, 7. That's it. Okay. Now I want you to focus on this more carefully. Okay. So see here, f of 3, 7. So f of 3, 7 means 7 means the index that is not present. That is not present. Whenever I gone too far, when there is a index not present, what should I do? I will just returning false. I just returning false. What this false indicates? This false indicates, hey, you have gone to the invalid path. So just return false. That's it. Okay. Now 7, 7. 7, 7 means, just try to understand, two pointers are lying at this same point called 7, 7. So from here I can tell you, hey, I have successfully constructed. That's the reason why two pointers are lying at 7, 7. Meanwhile, here it is 3, 7, which means I successfully constructed all the values up to 3, but I cannot finish any other values. That's the reason why it is 3, 7. Now it is 7, 7, which means I have successfully constructed all the values. Okay, so here it will be returning true. Similarly, here also it will be returning false. Similarly, here also it will be returning false. Now hope you understand why it is returning true and false, right? Now here it will be returning false. Here it will be returning false. Then here also it will be returning false. Then here, one side is true, another side is false. Any one of them true, I will be returning true. Because I don't want to have, if all the parts is true, then only I want to return true. Not like that. In any one scenario, if I able to construct it, then it's fine, right? So I will be returning true. Here it will be false. Here it will be true. Here also again true. Here also again false. Now here it will be returning true. So true is going to be my output. So from this I can able to tell you that in any one of the path we got true, then the entire series will be giving the output as true. That's it. Okay. So hope you understand this approach. Now tell me, what is the time complexity you have taken here? So the time complexity will be O of, so see here, listen this carefully, we have taken two pointers. Okay, two pointers, but their size is going to be n only. Their range will be going to be n only. But for one recursion, in worst scenario, we will be having like this, two recursion calls. So for n square recursion calls, we have 2 power n square. So 2 power n square is going to be your time complexity. Meanwhile, your space complexity will be, 2 power n square, and also we want to check in this verdict, right? We want to check in this verdict, and also we want to take the substring. So into n for the substring in the worst scenario, into r plus. So this will be inside the recursion. In coding, you can understand this clearly. Okay. Now just try to understand, plus n. Okay. If I am using the verdict as a array, if I am using the verdict as a set data structure, then my time complexity will be something like O of n 2 power n square into n plus log n. Okay. Anyhow, we will be getting as, in approximately it will be 2 power n square cross n. Okay. Now what is space complexity? It will be O of n square because of the recursion stack. So these two things are going to be more important. Okay. So let us see the code, then we can come back and optimize this further. So see here, this is going to be a Java code. If you want C++ or Python code, just search in the description. I have given that. Now at first, where should I start? I will be starting from 0, 0. Okay. So I call the function DFS. As you know, our recursion is always a DFS. So that's the reason I kept the name as DFS. Okay. Now, what are two base conditions we have? So base condition is one is if I is equal to s dot length and also j is equal to s dot length. Okay, then only I want to return true. If any one of them like our j pointer will be reaching the s dot length at first, right? At first, either you can put like here r, the same condition and put r, or else you can just put like this, like see here, your j pointer, your upper pointer in my drawing when the upper pointer reaches the end, but my lower pointer is just at some valid index, then I can tell you we are not completed that sequence, we are not completed that string. So that's the reason why I'm returning false. Can you understand this two base condition, right? Now take is equal to false initially. So when I should take, whenever my substring from I to j is present in my word dict, then only I can able to take condition. I can go to take condition. So what is the take condition? It will be I plus 1 and j plus 1. Sorry, j plus 1 and j plus 1, because 2 pointers will be moving to the 2 pointers will be like this. So 2 pointers will be moving to the upper pointer plus 1. That's the reason why I put like j plus 1 and j plus 1. In not take, we don't have any condition and we will be moving our j to plus 1. That's it. So for everything, the not take will be condition will be applied, but the take condition will be only when the condition is true. Okay. At last, if any one of them is true, then I'll be returning true. Hope you understand this. Now let us take this and optimize this. So see here, the next step we are going to do in this recursion is going to be memoization. So from the name itself, you can able to understand what is memoization. We are going to store something in our memory so that whenever it is came again. Sorry, just a minute. Yes. Whenever it is came again, we will be just taking from the memory instead of going back again to the recursion call. For example, see here. Here there is nothing like that. But in some scenarios, like here it is 3, 3, right? In some scenarios, in some cases, there will be 3, 3 occurring again. In this scenario, instead of again for this 3, 3 going to all the recursion calls, instead of that, whenever I am just found out this result at first, I will be storing it in my memory so that when it is again occurring, instead of going to the all recursion call, directly I will be sending the return value from my stored memory. Can you understand this? So by using this entire time will be reduced. Okay, which means our time complexity will be of n square from 2 power n square. Okay, there are some set of rules to convert recursion code into memoization. Let us see that. First of all, the construction of array or hash map. Okay, so we can do either using the hash map or we can also do using array. So I'll be doing using the array because array will be more efficient, and by using the array we have some advantages over the hash map. If you want the hash map solution, just try by yourself, okay, after watching this array, because hash map solution will be so much easy. Fine. Now the first condition is we want to find out what is the dimension of the array. Okay, to find out the dimension of the array, check what is the varying parameters. So the varying parameters are I and j. So here I can tell you it's going to be 2D array. Okay, so that's going to be the first condition. Now the second thing is we want to find what is the array size. So see here the array is starting from 0. Sorry, here the I value is starting from 0 and going up to where? It will be going up to s dot length of -1. If it is s dot length of, then I will be surely returning any one of the value from the base condition, right? So my I value will be from 0 up to say n-1, right? In more formally. Meanwhile, j will be also from 0 to n-1. Can you understand these two things? So obviously my array is going to be n cross n matrix. Okay. For example, if I have some example like this, so cats and so this is going to be my example. Okay, here are totally of 7 length. So my array will be also containing a 7 cross 7 matrix. So 0, 1, 2, 3, 4, 5, 6 and 6. Okay, here also similarly 0, 1, 2, 3, 4, 5 and 6. Okay, so this is how my matrix something looks like. Can you understand this? So that's it. So 7 cross 7 matrix. Now the next step is what is going to be the individual initialization value. So observe this carefully. What are two values will be possible in this question? So the two values are either it can return true or it can return false. So I want to initialize some value which is not equal to true, not equal to false. Maybe you can initialize like null. Simple, right? So initialize everything as null because it will be helpful in your memorization technique. Like just for a moment, I will be telling you two lines, then you can understand this clearly. Okay. Now in this base condition, I want to add one more condition. Like if take for example this array name is dp. Okay. If dp of I and j is not equal to null, then just return that particular index of dp. That's it. Okay. Similarly, before this return, just strike out this return. Before this return like dp of I and j will be updated as take or not take. Okay. Then return it. Then return dp of I and j. That's it. Can you understand this? Yes. So these two lines are updating my dp array, and these two lines are just checking whether it is already computed or not. If it is already computed, then don't worry, just return it instead of going to the all other recursion calls. Okay, now can you understand why I am initializing everything as null, right? So here I am using null. Okay, fine. So this is how we want to do a memorization technique using array. Now tell me what is the time complexity. So time complexity will be O of n square. Meanwhile, space complexity is also O of n square. So this is what that overall time and space complexity. But I forgot to tell you, it will be n square cross n. Meanwhile, space complexity will be n square because we are using what? We are using a substring. And also we are checking in the dict array. Okay, so that it will be almost n cube. Okay, fine. So the space is because of two things. One is because of the matrix we have used. Another one because of the recursion stack we have used. Because the recursion will be obviously using a auxiliary stack called recursion stack, right? Now in next step we are going to eliminate this recursion stack. Before that, let us go and see the code. Okay, so see here, let me comment this out, then let us get into the memorization. So see here, this is going to be a memorization. Yes, so here, so this line is newly inserted, the dp, initializing the dp as a 2D matrix, and also its length going to be n cross n, and defaultly it will be initialized as null. Hope you understand up to this. Okay, now the next step is here I have inserted one line, I have written a drawing explanation. At last update it, then return it. That's it. By doing this, now if you submit this, it will be submitted successfully. Because see here, what is the time complexity? Sorry, what is the constraint they have given? It is 300, which means 300 into 300 will be 6 into 10 power 4, right? 6 into 10 power 4. So 6 into 10 power 4 into n cube is our time complexity, right? N cube is a time complexity. So this, for this scenario, it will be like 300 the whole power cube. Okay, so this will be less than or equal to my clock time. That's the reason why it is submitted successfully. Can you understand this? Okay, so let us take this, then let us get into the next part. Yes, so the next part is tabulation part. Okay, as I already told you, right, we want to eliminate the recursion stack. To eliminate the recursion stack, we want to get into the tabulation. Okay, for tabulation we want to also follow some more steps. Okay, so tabulation is quite harder than converting the recursion into a memorization. Okay, so let me teach you so that it will be more clear. So see here, first of all, in tabulation, let me again construct the array. So for the previous example of length 7, I have constructed 0, 1, 2, 3, 4, 5 and 6. So this is what our array looks like, right? 0, 1, 2, 3, 4, 5, 6. Yes, okay. So this is what the previous array looks like in memorization part, and everything is filled as null. Okay, fine. Now in here we want to check for the modification or for the alteration in the array. Like first of all, check for the base condition. So these two are the base condition, hats off now, right? So what this base condition means? This base condition means, hey, if my I is equal to s dot length, which means 7, and j is also equal to 7, then what should I do? What should I do? I'll be returning true. But here, whether I have I as 6, sorry, I as 7, so these everything will be I, and this everything is j, right? Right? So whether I have any index called 7, no. Then add it. Then add it. That's it. Okay? Add here also. Because we want 7 as the index for I and j. So that's the reason why I added here. So how my matrix dimension looks like now? It is n plus 1 cross n plus 1. Can you understand this? So this is what the dimension now looks like. Okay? Okay. Come up with me. Now, whenever my I and j is equal to length, what should I return? I should be returning true. Then go to the 7 and 7 and make this as true. Make this as true. Can you understand why I am making this as true, right? Now, s is equal to length and I is not equal to s dot length. Then return false. Return false. Which means that's your wish. So here it is an additional condition that it's up to you. It is your wish. You can either put everything as false, except this you will be putting everything as false initially, okay? Or else you don't want to put false also, because we will be taking this value and then building rest of the values, right? So that's the reason why if you want, you may put everything as false, because that's what the condition also, right? I am lazy to put that condition. That's the reason why I just neglected it, okay? Now just strike out this, okay? Now come to this. So these lines are going to be your body of the recursion, right? Whenever we reach the body of the recursion, put a for loop. So here we are going to eliminate the recursion, which means we are going to convert the code into a probably a looping. So now for, so my I value will be from where to where. Here my I value is starting from 0 going up to n minus 1. So obviously here it will be starting from n minus 1 going up to 0. Can you understand this? Do a reverse fashion. Okay. Similarly for j also, do a reverse fashion, because here it is starting from 0 and going up to n minus 1. So obviously reverse it. Okay. So let us take this as a dp. Okay. The name of the matrix is dp. Okay. Now get into the first line. So just write the first line as it is. So boolean take is equal to false. Okay. Now the condition as it is. So if the condition will be as it is. Okay. Now the take condition. So take is equal to, so here comes DFS. DFS means what? Is a recursion call. Whenever there is a recursion call, write dp of what is the varying parameter j plus 1 and j plus 1. Can you understand this? Yes. Now similarly after this if, okay, write like not take is equal to dp of I and j plus 1. Hope you understand this, right? Now at last, what should I return? After this entire for loop, what should I return? What is the value we are returning actually here? 0, 0. The function call of 0, 0. So here you want to return dp of 0, 0. That's it. So now I can tell you our tabulation code is ready. So what is the time complexity? Time complexity will be n cube, but space complexity is also n square. But this n square is because of the matrix we have used, not because of the recursion stack. Okay, so let me show you the code and let us check for once with the drawing expression, then you can understand it. So see here, this is going to your code. So first of all, what the alteration I have made, n plus 1 and n plus 1 as a dimension. Then the 7th index and the 7th row, which means n and nth row and the nth column will be made as true. The last row, last column is made as a true. Can you understand this? Okay. And your wish to put all the remaining as false, but I am not putting it because see here we are not taking this dp of I and j as a result of the dp of I and j. For this we are just directly updating it. That's the reason I didn't took all others with the false. If you want to take it, take it. Okay. Now these two conditions I have already mentioned in the drawing expression, and rest of the lines will be same as I mentioned in the drawing explanation. So it is very easy, right? Okay. So that's going to be your overall tabulation code, and I have done a small mistake here. See here it is j is greater than or equal to I, right? So, but in drawing explanation, I didn't return that. So I forgot that. Okay. So always remember, our I should be always lesser than or equal to j only in the recursion call itself. So that's the reason why I wrote here also. Okay. So I didn't told that in the drawing explanation. I forgot that to tell you. So that's it. So up to tabulation, and I tried for the space optimization, but I cannot come up with the space optimization, and I pretty much sure that there is a space optimization technique for this problem, but I don't know how to do that. So if you know about the space optimization technique, just comment below and explain it some clearly so that I can understand it. Okay. So I don't know how to space optimize this. Okay, fine. So if you really like this video and if you're able to understand all these three approaches, all these optimization techniques, then please like this video and subscribe to my channel, and don't skip any videos on the DP series, because all DP series will be helpful once you are getting into a competitive programming. And if you have any doubts or suggestions, or if you found any wrong, then just comment below. I'll be commenting the answers for it. Okay, thank you.